Hi, today in geometry, our lesson is called line segments and distance. So the first thing we're going to talk about is what it means for one point to be between two other points. On this line segment PQ, it says M is between points P and Q if all 3 points are collinear, so they follow along the same line, and the measurement PM plus the measurement MQ is equal to the total PQ. That is the definition of between. Now, whenever you see these letters PM, that means the distance between P and M, how long that is. So those are like numbers, whatever, we don't know them, but they represent numbers. The definition of congruent segments are segments that are equal in length. So if we have AB is equal to BC, which is equal to 3 centimeters, then we can put little slashes or tick marks on them to show on the figure that these two segments, AB and BC, are congruent, which means the same shape, same size. Okay, let's go down here. We'll skip over the completed examples and do some examples together. It says, find the measurement of each segment. Assume that each figure is not drawn to scale. You will see that quite commonly in geometry class. They want you to use the given information in the picture and not just your visual assessment of the picture to nothing subjective to determine your answer. So they want us to find the measurement of segment RT. We know from R to S is 2 centimeters and from S to T is 2.5 centimeters. So what do you think we're going to need to do with these measurements in order to get the total distance from R to T? Hopefully you decided you should add those. So you can go 2 plus 2.5, which equals 4.5 centimeters. All right, number 2. We are supposed to find the length of segment BC. So the total segment from A to C is 6 inches, and from A to B is 2 3/4 inches. So how would we get this little piece BC if we know the entire distance from A to C and then this left side piece from A to B? Hopefully you thought that you would take your big one and subtract the small one to get the remaining part for BC. That's what we need to do. So you're going to go 6 minus 2 3/4 inches. You should have learned how to subtract mixed numbers in middle school at some point. If you do not remember, you're welcome to use a calculator. 6 minus, if you hit alpha, y equals, option 2 is UND, that's for units and a numerator and a denominator, which will give you your mixed number. So you can do it that way, and you'll get 13/4, which is an improper fraction. 13 divided by 4 is the same thing, which is 3.25, so there's your decimal answer. Or your answer is a mixed number. 0.25 is 1/4 of a whole, so it would be 3 1/4 inches. Any of these answers is fine. 13/4, 3.25, or 3 1/4. If you were to ask me which I would prefer that the answer be most like the information given in the problem. So since these were mixed numbers, I would prefer the mixed number answer, but I will accept any of them. Okay, so then the next one, we are supposed to find the distance between point X and point Z. And we know from X to Y is 3.5 inches, and from Y to Z is 3/4 of an inch. So what do we need to do with these two numbers to find the total distance from X to Z? Hopefully you thought we should add those. So 3.5 plus 3/4 of an inch, perhaps you can add that in your head. If so, just jot it down. If not, you can use your calculator to do this. Alpha y equals, option 2 will give you your mixed number, 3 1/2. and then you can go plus alpha y equals option 1 for numerator over denominator with no units digit, 3/4, and enter. That gives us 17/4, which is a fine answer. As a decimal, that would be 4.25, or 4 1/4 as a mixed number. All of those are equivalent. Any is fine. Okay, so number 4, we have segment WX. So for segment WX, it says the entire length from W to Y is 6 centimeters, and we're supposed to find this one, which kind of looks like the one above it where we subtracted, but we don't have the number on the other side to subtract away from the 6. So how do we do this one? Well, in this particular problem, it's important that you notice these tick marks or slashes on the picture. If you will recall, those mean that these two pieces are congruent to one another, so they are the same length. So in order to find the distance from W to X, we just need to take the 6 and divide it by 2. What is 6 divided by 2? It equals 3 centimeters. Okay, the next set of problems are algebra problems. We use a lot of algebra problems in geometry class because after you take geometry, you take algebra 2. And so in algebra 2, you're going to use skills both from algebra and from geometry. So we want to make sure that you're good at both of those before reaching algebra 2. So we definitely wouldn't want you to skip a year of doing any work with algebra where you would get rusty and have more difficulty. So these are not very difficult algebra problems, so I will help you with them. It's fine if it's a little bit rusty because it's been a while since you've worked with any of this. It says to find the value of X and RS. Notice we're finding two things, so there's going to be two answers to each of these problems. If S is between R and T. So what does that mean if they are between? That means that we should have a line segment where you've got an R and a T on each end, and then the S is somewhere in between. We don't know if it's closer to R or closer to T or right in the middle. Between doesn't tell us how far it is from either end. It just says that it is on that line segment where the distance from R to S added to the distance from S to T would equal the total distance from R to T, as discussed earlier. So for these problems, we're going to need a little bit more room to work than what we have right here. So I'm going to use a separate sheet of notebook paper to do this. I'll go ahead and draw that line segment up here at the top again. Endpoint R, endpoint T, and a point S somewhere in between. So for number 5, they told us RS equals 5x, ST equals 3x, and RT equals 48. So for this particular problem, the RS is 5x, that goes here. The ST is 3x, that goes here. And the total from R to T is 48. So I need to write an equation that ties these three pieces together. Remember, since S is between, that means RS plus ST would equal RT. So that's how I'm going to set it up. 5x plus 3x equals 48. So this problem is very much like problem number 1 that we worked, except for instead of adding up two numbers, I'm writing two variable expressions and adding those together, setting them equal to the total length, writing this equation. So once we've written our equation, we need to solve for x. So do you remember what you get when you add a 5x plus a 3x? It's kind of like adding 5 apples and 3 apples. It's going to be 8 apples, or 8x here, equals 48. This means 8 times x equals 48. We want to get the x by itself, so we have to undo the multiplication. What operation undoes multiplication? The opposite of multiplication is division. So we divide both sides by 8. So x is equal to 48 divided by 8, which gives us 6. And that is one of the 2 answers for this problem. Remember, we said there was going to be 2 answers to each. The other thing that it asked us to do was, paper back out, find the value of x, we've done that, and rs. So remember, rs was equal to 5x. Now that I know x is 6, I can say rs is equal to 5 times 6, filling in the 6 where the x was. Multiply these together. 5 times 6 is equal to 30. So rs is equal to 30, and that's the other answer to problem 5. Okay, let's look at number 6. For number 6, the given information says rs equals 2x. st equals 5x plus 4, and rt equals 32. So this problem is very much like number 5, except for when we draw, when we fill in our values, the st is a little bit more involved than it was on problem 5. R goes here, T goes here, S is somewhere in between. So from R to S is 2x, from S to T is 5x plus 4, and this entire distance is 32 from R to T. So the equation that we will write is going to be this little piece 2x added to this little piece 5x plus 4 equals the total from R to T, 32. So now that we have our equation, we need to solve it for x. 2x and 5x can go together just like the 5x and the 3x went together over here. 2x plus 5x is equal to 7x plus 4 equals 32. We cannot add the 7x and the 4 because this one has an x and this one doesn't. They are not like terms. So I want to get the x by itself, and the way I'm going to get the x by itself is by undoing the operations that are here. So since I have a plus 4, I'm going to do the opposite of adding 4, which is subtracting 4 from both sides of the equation. So 7x is equal to 32 minus 4, which is 28. And then to get the x by itself, I have to undo the multiplication times 7 by dividing by 7 on both sides. And 28 divided by 7 is equal to 4. So x equals 4 for this problem. Now the other part, remember, is to find rs. rs is equal to 2x. They gave us that in the problem. So if rs is equal to 2x and x is equal to 4, that means I do 2 times 4, and that will give me 8 for the length of rs. All right, moving right along to number 7. Number 7 gives us rs equals 6x, st equals 12, and rt equals 72. This one is actually probably easier than the others. The st is an actual number. We only have one x in the problem. You might want to pause the video and see if you can do this one on your own. from R to T, the S is somewhere in the middle. From R to S is 6x, from S to T is 12, and the total distance from R to T is 72. So the equation that we could write here is 6x plus 12 is equal to 72. And now we need to get our x by itself. Since we have a plus 12, we do the opposite of adding 12, which is subtracting 12 on both sides of the equation. So now our 6x is alone. 72 minus 12 is 60. And then to get the x by itself, we have to undo the times 6. So we divide by 6 on both sides. And x is equal to 10. So that is the answer for x. Now we need to find RS. RS is equal to 6x in this problem. So we just do 6 times 10, which is 60. Okay. Next we have number 8. So for number 8, let's see. I'm running a little bit out of room on my paper. I'm going to go back up here to the top and draw a line and put number 8 here. So number 8 is RS equals 4x, ST equals 4x, and RT equals 24. So if I draw my picture, here's my line segment. Point R and T are on the ends. S is somewhere in between. RS is 4x, ST is 4x, and the total distance is 24. So now I'm going to write an equation. The two smaller pieces equal the whole length. So 4x plus 4x would have to equal 24. These are both like terms because they both have x's in them, so I can combine them. 4x plus 4x equals 8x, adding those coefficients in front of the variables. And now I have 8 times x equals 24. I have to undo the multiplication to get x by itself. The opposite of multiplying is dividing, so divide by 8, and x is equal to, what is 24 divided by 8? How many times does 8 go into 24? 3 times. So x is equal to 3. And now RS is equal to 4x. That's what they gave us at the beginning. So I'm going to fill in the 3 for the x. So that's 4 times 3, which gives me 12. The length of segment RS is 12. Okay, we made it through our algebra problems. Woohoo! Now we'll move along to, at the bottom, problem 9 and 10. Determine whether each pair of segments is congruent. Now, I'm going to show you, we have a symbol in geometry for congruent. They showed it up at the top. It's an equals with a little squiggle over the top. It means same size, same shape. So, look from A to B. Segment AB is, we're supposed to determine if segment AB is congruent to segment CD. And it says 5 centimeters on both. They're both line segments, and they are both the same length. So would we say that they are congruent? I think yes. And I'm going to say segment AB is congruent to segment CD. The reason we know that is because they're both 5 centimeters long. They're both line segments with the same length. Okay. Now on number 10, it says segment XY, which is this left side of the triangle, says 3x plus 5 here. It has a slash or tick mark on it. YZ, segment YZ, that's the bottom one. That one has 9x divided by 2. Let's see, this one doesn't have the tick mark on it. Notice segment XZ does have a tick mark on it. These two are the same for sure because they're marked congruent in the picture, but this bottom one doesn't have that mark on it. So how do we know whether it's the same also or not? Well, we're going to have to do some figuring to determine this. Since I know these two are congruent, I could write an equation and say 3x plus 5 must equal 5x minus 1. We know they're equal because of those tick marks in the picture. So now let's solve for x. So how do we do that? Well, we got to get the x's together on the same side of the equation. I generally like to start by getting my x's together, which is not the only way to solve this equation, but that's the way I prefer to do it. And I usually like to get the x's on whichever side has the larger x value to start. So since 5x is greater than 3x, I'm going to move this 3x over here to the side where the 5x is. But you can't just go moving things. Do you remember how you get that 3x over to the right side to combine with the other x in the problem here? You have to do the opposite. Since it's being added, we subtract. Minus 3x minus 3x. So this side will only have a 5 on it. And this side we do 5x take away 3x, which leaves us with 2x, and then that minus 1. So my goal is to have all the x's together on one side and all the regular numbers together on the opposite side. So I need to get rid of this negative 1. And the way I get rid of the negative 1 is I add 1 to both sides, because the opposite of minus is adding. So 5 plus 1 is 6 equals 2x. And then if I divide by 2, because these are being multiplied, so the opposite would be division, divide by 2 on both sides. 6 divided by 2 is 3. So x is equal to 3. Now, how did that help me? Well, I know what x is now, so I can figure out how long this side length is. Since it was 3x plus 5, that means it's 3 times x is 3 plus 5, which means it's 9 plus 5. And if you add 9 plus 5, that equals 14. So this left side of my triangle is 14. Now let's see how long the bottom part is. It says 9 times x, which is 3, then divided by 2. 9 times 3 is 27, and 27 is an odd number, so you get a decimal when you divide it by 2. And you can leave it as a mixed number. It's not 14, because 28 divided by 2 is 14, so this is not equal to this. So we're going to say no. Segment XY is not congruent. So I drew the congruent symbol but put a slash through it, which means not congruent to segment YZ. Now, if this problem had asked me if segment XY was congruent to segment XZ to begin with, I could have just said yes immediately and said they were congruent because of those tick marks in the picture. They have to be. But that wasn't what the problem asked, so there was a little more work to be done to determine that. Okay. Now we're going to go to the back of this paper and scoot on over to the next problem, which is having to do with distance between 2 points on a number line or on the coordinate plane. We're going to start with the distance between two values on the number line. So this might seem sort of easy to you, and that's okay if it is. We're going to jump down here to look at these exercises. I have a number line. The first thing I want to know is how far apart, use the number line to find each measure, are the points B and D. So first I want to locate, here's B, here's D, and I want to know how far apart are they, okay? what you need to do is count the jumps. So if I start at B and I jump to D, every time I jump, I count 1. So here's 1, 2, 3, 4, 5, 6. So they are 6 apart. Or I could have started with D and went to B. 1, 2, 3, 4, 5, 6. Either way is fine. Now, another way to do it is to take x1 minus x2, which means the numbers on the number line, and subtract them in absolute value bars. So if you end up with a negative, you just throw out the negative. When we're talking about the distance between 2 points, we're saying how far are they from each other. So we want that to be a positive even if you get a negative. So it would be -7 minus -1. So if you do that, say on your calculator, -7 minus -1, that equals -6. But then you have to do the absolute value of that, so you just do +6. So there's a couple of different ways to approach this, and any of them that works for you is fine as long as you're getting the right answer in the end. So now we're going to look from D to G. How far apart are points D and G? So I'm going to start at D and count to the right. 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps, 7 jumps, 8 jumps, 9 jumps. They are 9 units apart. Now, from A to F, how far apart are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12 jumps. That's the distance between them. All right, from E to F. Well, these are really close. Jump 1, 2, 3 times and you're there. All right, I'm going to suggest that you pause your video and try the remaining 4 in this section, problems 5, 6, 7, and 8 on your own, and then restart the video to see if you got them correct. Okay, hopefully you've had time to check those out yourselves. From B to G is a big distance. That is 15. Did you get 15? Woohoo, good job. Okay, for number 6, from A to G, well, those are the farthest apart of any 2 points on this number line that are labeled, and that comes out to 17. Did you get 17? I bet you did. Okay, number 7, from B to E, how far apart are points B and E? Those are 7. And finally, from D to E, there's our smallest distance, only 1 jump apart. All right, if you're having any trouble with those, please ask for help. Let me know. Come in for tutoring, email me. We can set up a Google Meet if we need to, but we'll get this figured out if you're having any difficulty at all. Okay, next section and final section here is the distance formula. So the distance formula is up here at the top of the page. It is a lengthy formula. The distance is equal to the square root of, and that's a big long square root. You take an x2, which is the first coordinate, minus the x1, which is the first coordinate of the other point, in parentheses squared, plus y2, which is your second coordinate, minus y1 on the other point, in parentheses squared. Now, you do not have to memorize this formula. It's on your formula chart that you will be allowed to use in this class. But you do need to know how to use it when it comes up. So, and it's going to come up a lot this year. It's a lengthy formula. It is used quite frequently in geometry class. Just when you've kind of forgotten about it and thought it wasn't coming back, it's going to keep coming back again. So, very important that you understand it and how to use it. I'm going to go ahead and write the formula down here near our problem set so that it's handy. The distance is equal to big long square root x2 minus x1 close parentheses squared plus y2 minus y1 close parentheses squared. So we'll start with problem 9. The first step is going to be to label the points. So you label them x1, y1, x2, y2. X comes before y in each point, and this is the first point, so they have 1s. This is the second point, so they have 2s. And technically you could switch the first and the second point and it wouldn't matter, but both 1s need to be in one and both 2s need to be in the other. I just always label them the same way for consistency, and it helps you to keep track and not make mistakes. So now I'm going to write the big long square root and fill in the numbers where they go. So I start with an open parentheses, and then I put my x2 number. My x2 for this problem is 6. 6 minus my x1. x1 for this problem is 0. Close the parentheses, squared, plus new parentheses. y2 is 8 for this problem, minus y1 is 0, close parentheses, squared. And I'm even going to extend my little square root a little because it wasn't quite long enough. Now, some of you can work this out in your head without using a calculator. 6 minus 0 is 6. 6 squared is 36. 8 minus 0 is 8. 8 squared is 64. 36 plus 64 is 100. And the square root of 100, what number times itself equals 100? That gives you 10. So some of you can do that in your head. If you can do that in your head, that's wonderful. Go for it. Do it. If you need to use a calculator, that's fine too. You're going to hit second, which is the blue button in the top corner, and then you're going to hit the square root button, which is the x squared button, the one just below that. So the square root is right there. Then you're going to do an open parenthesis, which is above the 8, and you're going to type 6 minus 0. Then you're going to do the closed parentheses, which is above the 9, and then you're going to hit the x squared button to get your little 2 up there. Then you're going to put your plus and then start a new parenthesis, that button above the 8 again, and then you do 8 minus 0 inside the parentheses, close the parentheses, that button above the 9, and then hit the x squared button to get the little square on there. You got all that typed in, press enter, and you get 10. So that's how we do that. With the calculator or without the calculator. Either way is fine. On the distance formula problems in this course, you will have a calculator to do that. Your tests will often be comprised of a calculator and a non-calculator portion, but this generally will fall on your calculator portion because some of the answers are going to be what we call irrational numbers, which are numbers that have decimals that do not terminate or repeat, and you cannot determine those values without using either a calculator or an old-fashioned table of values, which we generally don't use anymore. So for number 10, let's move on. We've got an x1, y1, x2, y2. That first step is just to label the points. Then we draw the big long square root, open parentheses, start with our x2, that's 3, minus x1, which is negative 2, close parentheses, squared, plus new parentheses, y2 is 15, minus y1 is 3, close parentheses, squared. And that's what we type in the calculator. Clear, square root, parentheses, 3. Now I want you to notice this is minus negative 2. Your calculator has a different button for minus and negative. So minus goes between two numbers, negative just is in front of a number. So we've got the minus is on the right with the plus, and then the negative is down at the bottom next to the enter button or next to the decimal button in parentheses. So when you type the minus, it goes like right in the middle of the numeral, and the negative is shorter and a little higher. If you put the wrong one, negative when it's supposed to be minus or minus when it's supposed to be negative, it is possible to get either an incorrect answer or an error message depending on the context of use in that problem. Oh wait, so then I've got 2 under the parentheses, under the square root, sorry, then close the parentheses, x squared plus new parentheses 15 minus 3 close parentheses squared. Everything is under the square root. If you hit the right arrow, it's going to go outside the square root, which we don't want. So you would have to hit the left arrow, these are your arrow keys, to get back under it if you accidentally do that. So we're going to press enter, and this gives us 13. Now you might have been able to do that by hand, because 3 minus negative 2 means 3 plus 2, which is 5. 5 squared is 25. 15 minus 3 is 12. 12 squared is 144. 25 plus 144 is 169, and the square root of 169 is 13. So feel free to do this without the calculator if you prefer. Next, let's see. I don't think I'm going to do all of these. I'm going to let you pause the video and try to do these on your own, and then I'll come back and give you the answers so you can check them, and I will do one more. I'll do number 16 with you. So why don't you try 11, 12, 13, 14, 15 on your own. Pause the video, give those a try, and then you can replay it, and I'll do number 16 with you. Okay, so for number 11, you should have gotten the square root of 9 minus 1 squared plus 13 minus negative 2 squared, and that equals 17. For number 12, you should have had the square root of negative 9 minus negative 12 in parentheses squared plus 6 minus 2 squared, and that should have come out equal to 5. On number 13, you should have had the square root of 15 minus 0 squared plus 20 minus 0 squared, and that comes out equal to 25. Number 14, you should have had the square root of negative 8 minus negative 12 squared plus 3 minus 0 squared, which equals 5. And for number 15, you should have had the square root of 6 minus 11 squared plus 2 minus negative 12 squared, which is not a nice number like the other 6 previously. You're going to get a decimal. And I didn't tell you what to round to. Let's just round to the 10th place. So 14.9 is what we would get there. All right, now I'll do number 16 with you. First step, label it. x1, y1, x2, y2. Draw the big long square root. Fill the numbers into the formula, starting with x2. x2 is negative 4 minus x1 is negative 2, close parentheses, squared plus new parentheses. y2 is 3 minus y1 is 10, close parentheses, squared. And that's what we'll type in the calculator. So second and the square root button, parentheses, negative 4 minus negative 2, close parentheses, squared, plus new parentheses, 3 minus 10, close parentheses, squared, and this is equal to 7.28. I said round to the 10th place, one number after the decimal. It's a 2, but the number following it is 5 or greater. 8 is greater than 5, so it's going to round up to a 3. So the answer would be 7.3. Okay, Now we just have one last little thing to learn today as part of our lesson, and that's our first construction. It's a pretty easy construction. I think that you will be successful with it. You do need two special geometry tools to do this. You need a straight edge, which we often use a ruler, but technically it doesn't have to have any markings on it. It could just be blank. And you need a compass. I have a nice metal compass. Most of the ones that they sell at H-E-B and Walmart and Amazon and such are plastic. You can get one for a couple of dollars. That's fine. Those ones usually you just pull the arms and legs open, but on mine it has a little wheel in the middle that you turn to widen it or to close it. Now if you turn it too far, it will all come apart, so you have to be kind of careful with it. On the bottom of your compass, it has two legs. One has a pointer on it and it is sharp, so you do need to be careful with this geometry tool. The other side has a pencil lead. Some of the ones that they sell in the store, you actually just put a pencil in and tighten it so it actually holds a real pencil. But this one just holds the lead from a pencil, like if you just get the little packages of lead. So it doesn't matter what kind of compass you have, any compass is fine. But we are going to learn how to duplicate a line segment. This is how the historic mathematicians did this without the use of any computers or technology, making very accurate geometric drawings. So it's sometimes kind of interesting to see how we can make these pictures, because a lot of important information can be deducted from a very careful geometric drawing. So the steps are listed down below, and we're just going to follow these steps to do this duplication of a line segment. Duplicating means like copying or replicating or making a equivalent version of, so there's a lot of different synonyms for duplicating, but basically we are doing a geometric construction, and we're going to learn several of these in this unit, so this will not be the last one by any means. This is a way of drawing very accurate geometry figures using only a pencil, a straight edge, and a compass, and not using any measurements like the numbers on the ruler or the numbers on a protractor or anything like that. So number one, draw a ray with an endpoint C. So in the blank space here, I'm going to take my straight edge, and I'm not even going to have the number sign up because I just need to make sure I draw it longer than that. And it can be a lot longer than that, line segment AB, but it definitely needs to be longer. Better to be too long than too short. And then it says the end point is C. So I'm going to put a point right here on the end and call it point C. And next, I'm going to take my compass, and using the compass, I'm going to measure the length of AB. That does not mean like you measure with a ruler to find the number that marks it. What that means is put the pointer on one end, and it's not on the letter, it's on the end of the segment. And I'm going to extend my compass until the pencil end is on the opposite side. And to make sure that I've got it just right, I'm going to make an arc. This arc, when I grade your construction, is part of the grade. I should see this on your paper. So it said right here, mark B with the compass, which is what I just did, making that mark. Now, keeping your compass rigid, this is very important. Whenever you see the direction, keep your compass rigid. That means do not make it bigger or smaller right now. We need that same distance set up on your compass for the next step. Put the sharp end of, oh, that should say on point C, and then create the same arc and label it D. So put the sharp point on C and make a little arc where it hits the segment is going to be our point D. Now, segment AB is congruent to segment CD. Do you remember the way we mark congruent segments with a little tick and a little tick, or a little slash and a little slash? Or you can do double slashes if you prefer. They need to have the same number though to indicate that they are equal to each other. Okay, so when you do your constructions, do not erase any of your construction marks. That is part of showing me that you have followed the procedure, because the wrong thing to do would be to measure this with your ruler and then draw it to this length. The human eye has a lot of variability in the measurements that it sees from one person to another, and this is a much more accurate way to make equal segments than eyeballing it on a ruler. Okay, that concludes our lesson for today. I hope you've learned a lot, and I hope you have a wonderful day. See you soon. Bye.